In the context of climate change, cropping systems need to be adapted to make them more resilient. One way of doing this is to select new varieties that encourage interactions between the soil and the plant to improve the efficiency of water and nutrient use. Among other things, an efficient root system enables plants to tolerate stressful climatic events such as drought or excess water, while making a greater contribution to storing carbon in the soil and reducing greenhouse gas emissions. Studying the root system, which is by definition underground, is more complicated than studying the above-ground parts of crops and requires appropriate phenotyping methods. As part of the Root to Res project, funded by the European Union, we are evaluating different techniques for characterizing the root systems of crops, particularly potatoes. The shovelomic method is the most widespread technique. It allows access to the root system of plants in the field with just a shovel. Shovelomic sampling is a fairly simple method, requiring little equipment and can be carried out regardless of soil type. This technique involves taking samples from the top 25 centimeters of soil in the mounds and characterizing the root system and stolon development. In the case of potatoes, we take a sample of 2 plants from 2 adjacent rows in a representative area of the plot. These samples are then extracted with a shovel by 2 operators in order to collect the entire root system and potato tubers from the same top 25 centimeters of soil. The samples are processed directly on site. The mother tuber is then located to separate the main stem from the other stems. This results in 2 subsamples in which the stolons are separated into those coming from the main stem and the others. For the rest, tops, tubers, underground stems, and roots are separated. The biomass and number of tubers are then measured in fresh weight before being sent to the laboratory. The number of stolons on the main stem and their respective lengths are measured. The root samples and all the stolons are washed separately to remove any remaining soil residue before being scanned for image analysis. WinRhizo software is used to process these images and classify the total length of roots and stolons by diameter class. This measurement, coupled with the dry root biomass, enables acquisition of the specific root length, which represents the length of root per 1 gram of dry biomass. As part of the Root to Res project, we are also seeking to determine proxies between above-ground and underground development using sensors to speed up and multiply reference acquisition in the field. To do this, we have a wide range of sensors, such as the ALFI system and the Literal stick, which enable us to acquire data as close to the crop as possible, as well as more global measurements, such as those taken with drones.